Cones. So in this video, we're going to look at finding the volume and surface area of a cone. So a cone is a circular shape that comes to a point as a 3D object. And the important information on a cone is the radius of the circular face at the bottom. So we're going to need to know that radius. We're going to need to know the slanted length, which we'll call L. And we're going to need to know the height of the cone, which we'll call H. So knowing those three bits of information, the volume of a cone will be 1/3 pi r squared H, which is actually 1/3 of a cylinder, because a cylinder is pi r squared H, and it's just times 1/3. And the surface area is equal to the area of the circle at the bottom, which is pi r squared, it's the area of the circle, plus the curved bit of the cone, which ends up being pi r times the slanted length L. We can factorize this out to make it look a little tidier by taking pi r outside. We're left with r plus L. So you can use either one of those formula for surface area. So let's use that to do an example. So let's draw up a cone where we know the radius is 6 centimeters and the slanted height, the slanted length is 10 centimeters. So to do this, we need to know the height of the cone. It's not given to us, but we can find it using this right angled triangle and Pythagoras. So let's call that height H. 10 is the hypotenuse of this triangle. So we know H is going to be the hypotenuse squared minus the shorter side squared. So H squared. So H squared will be 10 squared, which is 100, minus 6 squared, which is 36. So H squared will be 100 minus 36, which is 64. Square root both sides to cancel out the squared. So H will be 8 centimeters. So we now know the height, so we can find the volume and surface area. Let's find the volume first. That's 1/3 times pi r squared H. So it's 1/3 times pi times the radius squared, which is 6, times the height of the cone, which we now know is 8, timesing 1/3 by 36 and 8 gives us 96 times pi centimeters cubed as an exact answer. And if we're rounding to the nearest centimeter, that'd give us 302 centimeters cubed to the nearest centimeter cubed. So let's find the surface area. For the surface area, we can use pi r outside of r plus L. So it's going to be pi times our radius, which is 6, outside of our radius plus our slanted height, which is 10. So it's going to be 6 pi times 6 plus 10, which is 16. And that's also 96 pi. But this time it's centimeters squared because we're finding a surface area. So in this cone, the surface area is actually the same as the volume. And if you're going the nearest centimeter squared, then it'd also be 302 centimeters squared to the nearest centimeter squared.